Hi, my name is Jim Barry, and I'm a solution engineer on Esri's transportation team, focused on the use of GIS with railroad organizations. For the next few minutes, I'm going to show you how you can use artificial intelligence to automate the task of detecting grade crossing fouling. What do I mean by this? Well, while often enough vehicle roads and railroads cross each other using overpasses and underpasses, quite often they cross at the same level. This is called a grade crossing, also sometimes called a crossing at grade or level crossing. As I'm sure we'd all agree, these types of crossings are inherently dangerous and are often accompanied by signals and crossing arms when they're in heavily trafficked areas. In addition, they can cause traffic issues. As we know, trains can be long and can travel slowly. I think we've probably all been in situations where we're waiting a few minutes or more for a train to pass. And in locations where there's only a few options for getting from A to B, wouldn't it be great if we could automate the process of knowing when a grade crossing is going to be blocked or is blocked and for how long? This kind of knowledge can help truck drivers make better route selection decisions. Also, local authorities can be notified, say if a grade crossing is blocked too long. Not only could it be good to have real time or near real time operational awareness of the grade crossing situations, but you can also automate the process of collecting data on fouling patterns in order to detect these patterns and problems that you may want to solve some other way. First, let's take a look at some examples of fouling. This first image here on the left is one where a locomotive is either moving or stopped at the grade crossing. We would consider that fouled, as in the train is fouling the crossing. This second image here in the middle is an example where the grade crossing is clear or not fouled. This third image is pretty much your choice. Some business rules would say that due to the relative maneuverability of trucks versus trains, a truck at this crossing is or isn't fouling it. Or perhaps it's considered fouling if the truck is stopped, but clear if it's moving. Bottom line here, the first step in automating this type of detection using artificial intelligence is to decide what you want to consider fouling. The choice is completely yours. Here's a dashboard that maps out a set of cameras around a maritime port facility. Being multimodal facilities, ports typically have a lot of grade crossings. And to keep things moving, it can often help to have better awareness about when they're blocked. Some ports only have a few ways to enter and exit. Here in the lower left are photos that are being taken once every 5 seconds. They're listed here above. For each image, we have a deep learning model trained to decide quickly whether a grade crossing is fouled or not. For example, here it is blocked, and here again. Here it says the blocked is false, and as you can see, the crossing is no longer fouled by the train. On this one, while the train is gone, the truck is now in the crossing, but in this case, we have decided to consider that as not fouled. And then here finally is an example of when the crossing is totally clear. To make this work, first we gather a few hundred photos with examples of the crossing being clear. And here a few hundred more showing the crossing being fouled, starting with this one here where the locomotive is partially touching the vehicle road. We've decided to consider that fouled as well. We should also gather examples at night since it looks different. In fact, here's an example right here where the cars are on the crossing, but since they are gone 5 seconds later, we consider them moving and thus not fouling the crossing. And then finally, nighttime examples of trains that are fouling things up. Here's a Python script that we use with those photo examples to build the AI. In short, if you can show the images to a person and train a person to tell the difference, then you can probably do the same to train a deep learning model. The AI routines are really good at finding patterns that it can rely upon when doing predictions. ArcGIS Learn is a Python module that comes with ArcGIS that contains many AI methodologies. And this module is specifically designed to be easy to use, abstracting away from you the need to know what's going on under the hood. The routine we're going to be using for this example is called Feature Classifier. It contains the ability to pick up the patterns that we want it to learn. As you can see below, it only takes a few lines of code to make this work, and we have plenty of runnable samples for you to use. What this chart shows is that the more training data you have, the better the model will be trained and the better your predictions are going to be. Once the model is trained, then you can send to it new pictures of the grade crossing that it's never seen before, and it will tell you whether it thinks the crossing is fouled or not. Here below, you see a list of images, one every 5 seconds, and the results from each. Another neat thing that you can learn is not only whether it's blocked or not, but by counting the number of images, you can also know how long. This would be great data to collect and save for further analysis later. Finally, here's the same type of dashboard that we saw before, but this time we're receiving new images every 6 seconds. Not only are we collecting fouling data, but we can even change the symbol on the map so that when the grade crossing is clear, we turn the intersection green, and when it is fouled, we turn the intersection red. We can even send email or SMS messages out to the local public safety officials if the length of time the intersection is fouled exceeds your rules. Maybe you want to notify someone if the train is fouling the track longer than 5 minutes, or maybe if a car or truck is fouling more than, say, 15 seconds. That's totally up to you. So that's it. Just one handy way to use AI to automate the time-consuming, tedious process in a clever and reliable way. Feel free to reach out if you have any questions, comments, or suggestions about this. Thank you.